Okay, a relation. Do we know what a relation is? Yes, no, maybe so? A relation is a correspondence between two sets. In this case, our sets are x and y. So if I give you the points 1, 3, 2, 3, and 4, 6, this is a relation. Alright, we can either write it by doing coordinate points, or do y'all remember in algebra when you learned about mapping? What? The point 1, 3, I have 1, an arrow going to 3. The point 2, 3, 2, an arrow going to 3. And 4, 6. Is this ringing a bell? All right. Some things to know about this is an x corresponds to a y, and y depends on x. Y is your dependent variable, x is your independent variable. A set of all x's is called the what is the set of all your x values called? Domain. And a set of all y's is your range. Your domain is your input, and your range is your output. So a relation is just your set of points. A function is when you let x and y be two non-empty sets. A function from x into y is a relation that assigns to each element in x exactly one element in y. To summarize that, what is a function? We've learned, is this a function? It is. Why is this a function? So a function is when x does not repeat. We can do that by literally looking and seeing, does x repeat? Or what about on a graph? How do we know if something's a function? What's that called? Vertical line test. So if I have this mapping, what points did I just map right here? What point do we have? -5, -8. What else? -1, -8, and 4, 8. Is this a function? Yes. Even though the y repeats, that doesn't matter. A function is all about x. X does not repeat, you're good. Questions? Hello, how are you? Good. Oh, yeah.
Here's all of our stuff for
I read it all. You want to give this to me? Or?
I highlighted stuff just in case, because the questions that'll be asked, I'll tell you about those later.
Okay.
When's your conference period?
5th period.
I'll come by tomorrow.
Okay, sounds good. What are my points here? -5, -8 again. What else? -5, 2, and 4/8. Is this a function? No, why not? X repeats, so this is not a function. Sound good? Okay, you do example 1, A, B, C. I'm going to give you like 1 minute to do all three. Remind me to tell you something when I'm not recording. Just remember. All right, your minute's up. Number 1, is this a function? Yes. Why is it a function? X does not repeat. All the X's are different. B, is this a function? No. Why is this not a function? -3 repeats. Can't have that. And the one that's probably the hardest on here, is this a function? What does this graph even look like? It is a sideways parabola. So do y'all agree y equals x squared is a parabola? So x equals y squared is like this. And is that a function? No, why not? It does not pass the vertical line test. All right, am I moving too fast? Be honest with me. We're okay? All right. Now, with is it a function or not, now we're going to talk about function notation. If the following values for the given function, find the following values. If I give you f of x equals x squared minus 3x plus 4, and I tell you what's f of 3, what am I asking you to do? You are plugging in 3 where x is. Y'all, what is 3 squared? 2 times 3 squared. What is 2 times 3 squared? 18. Please be careful. You need to do the squared first, then multiply by 2. PEMDAS. Exponent comes first, then multiplication. So this is going to be 18 minus 9 plus 4. What does that give me? So f of 3 equals 13. What about f of negative x? What am I going to do for the second one? I'm going to not plug in negative 1. What am I plugging in? Negative x. Because it's an x in the x, it's going to leave you an equation. What is negative x squared? Just x squared. And that's going to leave me positive 3x plus 4. Do you see how up here I identified f of 3 equals 13? All right. I'm fine with, as long as you have like an equal sign going all the way through, I'm fine with it like that. I'm probably going to add it just to the end so you identify the answer. Okay? What about C, negative f of x? How is this different? The negative's out front and you're just going to write the equation. And what does this do to my equation? It's just going to change all the signs. I want you to do the next two on your own. Be careful with that last one. You are going to have to FOIL. Do you agree when you add them together that's like doing 2 times f of x? So you should get 4x squared minus 6x plus 8. Alright, for this one, be careful. Does everybody see what I did right here to here? Foiling them. And also right here, be careful. Did you distribute that negative and get negative 6n right there? A lot of people last period were getting positive 6n, but it's negative 3 you're distributing. This gives me 2 plus 8n plus 8n squared minus 6n plus 1. Combine your like terms, and that is what I get. Do I have any questions on how I did that? Ask me. Do you get how I went from here to here? Are you sure? Did we just mess up? Oh, that's okay. As long as you understand it, that's all I care about. Mistakes will happen. If you're good on this, I would like you to do A, B, and C for the next, or no, F, G, and H for the next part. Don't do I. F, G, and H. It's the same equation. You're just doing more function notation plugging in. F, G, and H. What? That is what I was talking about. So we'll talk about it. Yeah. We'll talk about it. Don't you worry. I got you. Can I change this? Has everybody got that? All right. For this right here, we're plugging in 2x. So again, what is 2 times 2x squared? Be careful. 2 times 2x squared. 8x squared. Does everybody see how I got 8x squared? Because you got to do 2 squared and then multiply that by 2. I got minus 6x plus 4. Are we okay with that? Y'all, what's f of a? It's literally the same thing, but instead of x's, it's literally the same thing. All right, f of a plus h, you're going to have to FOIL. Go, if you haven't already done it. Right? I can't combine any of those. Is that a mouthful or is that a mouthful? I. So this is what I was talking about earlier. I is something called the difference quotient. I'm pretty sure in college algebra you're going to have to like memorize this. And here, if we ask you anything about it, it'll be like leading up exactly like this. Hey, find this, and now do this. Does that make sense? All right. So what am I going to do to find this value? Well, didn't we already find f of a plus h? Didn't we already find f of a? So can we take these two answers and just subtract them? Yes. That's exactly what we're going to do. So I'm going to do f of a plus h, which is this right here. Minus, and then whenever you subtract them, what are you going to have to do? Say that again. I'm going to have parentheses when I subtract them. So f of a was and all of this needs to be divided by what? Little h. Again, if it does, it'll like literally lead you to each of these. Does that make sense? Like it's not going to be like, find the difference quotient, and then you just got to figure it all out. College algebra, they may do that. All right, look up real quick. I don't want to rewrite all of this because we already used enough of our lead. Do you agree this negative distributes to all of these and changes the sign? So I'm going to make that positive and change that to a negative, change that to a positive. Are y'all cool with that?
Yes.
Thank you. Because ain't nobody got time for all that. So now what? Combine like terms. What do we got? The 2a squares cancel. What else? The 3a's cancel. The 4's cancel. So what am I left with? 4ah plus 2h squared minus 3h all over h. What can I do here? Take out the h's for all of them, and what am I left with? And this is my answer. All of that for this answer. Yes. For like plugging in, like function notation, yes. That's the messiest it'll get. That's messy. I would call that messy. Alright, now we're going to completely switch gears. We did function notation. Now we're going to talk about domain. What is domain? Your x values. What are your x values doing? So, for letter A, f of x equals 3x plus 2. When you're doing domain, I want you to think of what type of function is this? What is A? A linear function. Linear is a line. What is the domain of lines? All real numbers. And that is it. You could write it in interval notation. I just prefer the double back R. Was I okay to move on? Did y'all all get that? Okay. B. What type of function was B? Quadratic. What is the domain for quadratic functions? All real numbers. Parabolas go on forever in both directions. Negative infinity and positive infinity, it's all real numbers. So linear and quadratic, the domain, unless it gives you a restriction, is always all real numbers. What about C? What type of function is C? And if you divide two x's, what type of function is that called? It's a rational function. And right before spring break, we are going to have our test on rational functions. Yep. Now, rational functions. Those are the ones that go like this. Look up. They go like this. Do y'all agree those functions have asymptotes? How do we find those asymptotes, or what do we know? They have restrictions where in this equation? The denominator. So as a reminder, the denominator cannot equal 0. If you have a rational function, your denominator cannot equal 0. So x squared minus 25 cannot equal 0, which means x squared cannot equal 25, which means x cannot equal plus or minus 5. Does that make sense? So what is our domain? X such that x does not equal plus or minus 5 is how I would write it if I were you. All you have to memorize is the denominator does not equal 0. If you have a fraction, the denominator does not equal 0. Now, some of you prefer to write an interval notation. Is any of y'all like that? You prefer to do interval versus this, versus set? Personally, I would not write this one in interval because y'all mess it up. The answer here would be negative infinity to negative 5, union negative 5 to positive 5, union 5 to positive infinity. You guys tend to forget that middle one. So again, you already solved it like that. Just write your answer like this. Don't worry about that bottom part. Are we okay with that? You can write it, but again, there's just room for error. More room for error there. What's the last type of function that I gave you? Square root. And what do we know about square roots? It can't be negative. The inside must be positive, which means the inside has to be greater than or equal to 0. Write that down, please. For square root functions, the inside must be greater than or equal to 0. So my inside is 3x minus 15. It needs to be greater than or equal to 0. Add 15 to both sides. Divide by 3. X is greater than or equal to 5. So my domain is x such that x is greater than or equal to 5. Or in interval notation, you could write 5 to infinity. What questions do I have about domain? I want you to do example 4. Go. Did you set it up like that? Look up to see if you set it up right. In the parentheses is your x. The 2 is your answer with the y equals. So this is saying negative 2a, I'm cross multiplying, equals 8, or a equals what? Questions? All right, y'all pop your back. Roll your neck around. Page 3. We're doing all of page 3 and all of page 4, then we're done. Oh. And then you have a little bit of homework tonight. But your homework tonight is just copying me. So, tomorrow before you walk into class. It's okay. We're making up for missing yesterday by giving you homework tonight so that we can just speed through this week. You're welcome. I try. Alright. This year, earlier in the year, we talked about even and odd functions. Do you remember which trig function was even? Cosine. Does anybody remember why it was even? I did say it was, but why? An even function is even if and only if its graph is symmetric to the y-axis. Cosine was symmetric about the y. Remember it started at 1, 0, 0, 1, and then went down and back up? It did that on both sides. So, what is the even function that you probably think of most as far as symmetric to the y-axis? A parabola. Most of y'all are not going to think of cosine. You're going to think of a parabola. Y equals x squared is an even function. Y equals x to the 4th and y equals x to the 6th are also even functions. Oh, and guess what? Their exponents are even. We just said cosine was even. Can anybody think of anything else that is also symmetric to the y-axis? Secant, yep, secant works. What else? Not a trig function, just a regular function. Nobody? It is absolute value. That's a big one. Alright, these are just some of the even function. There are more. But on a graph, to look and see if a function is even, just look at the y-axis. Is it the same on both sides? Bam. Algebraically, a function f is even if and only if xy is on the graph, then negative xy is also on the graph. So think about a parabola. What is 2 squared? 4. What is negative 2 squared? 4. It does not matter if it's positive or negative. Do you agree they both are 4? Same thing. What is 5 squared? 25. What is negative 5 squared? 25. So, algebraically, if your f of x, y'all, equals f of negative x, it is even. Think of absolute value. What is the absolute value of 3? 3. What is the absolute value of negative 3? 3. So it doesn't matter if it's positive or negative. They have the same output. That's even. Okay? Odd. Odd is a little bit more complex, let's say. For odd, a function is odd if and only if its graph is symmetric to the origin. And by symmetric to the origin, I mean it rotates 180 degrees. The linear parent function is odd. Because if I rotate my paper 180 degrees and turn it upside down, do you agree I have the same exact graph that you have without rotating it? Yes. So, y equals x is odd. What else is odd? Tangent and sine. But don't worry, you're not going to have to graph those. Don't freak out. What else is odd? Cubic. Y equals x cubed. You'll see that by looking at A in just a second on the bottom. The other one I want to write down, you could write down y equals x to the 5th, 7th, 11th. All of those are odd as well. And then y equals 1 over x. The rational function we talked about earlier with the asymptotes. If I were to turn it 180 degrees, you'd still get this. Now, odd functions, a function f is odd if and only if x, y is on the graph, then negative x, negative y is also on the graph. If you remember from geometry, which I know you all remember, that's actually the rotating 180 degree rule. We got jokes today. Alright, so the algebraic way that I need you to remember is f of negative x equals negative f of x. That is how you algebraically can prove something is odd. So, look at the bottom. Just a quick glance. Do y'all have that written down? Quick glance. A, even, odd, or neither? Odd. Why is it odd? If I turn this around, is this the same picture you have on yours without turning it around? Yes. So it is odd. Write it down. B, even, odd, or neither? Even. Is it symmetric about the y-axis? Yes. C, even, odd, or neither? It's definitely not even, right? Because it's not symmetric about the y-axis. Is that the same picture you have on yours without turning it? Why not? Yeah, look at the y-intercept on yours. Look at the y-intercept on mine. Is it in the right spot? No. So this is neither. What about D? Add an arrow right here. I got two different answers, first and sixth period. Even, odd, or neither? Even. That is not what I got. It's what I got at 7 a.m., but not what I got at 1 o'clock. Why is this not even? Do they intersect at exactly the same spot? No. So, this is neither. Yeah, just be careful that it's symmetric and exactly the same. That is by graph. Can you easily spot a graph and realize if it's even, odd, or neither? Yes. Can I change this? Yes. What about an equation? Can we easily spot an equation? Not quite. Okay? You are going to have to do algebra to spot said equation. Now, look up, please. For this one, as a reminder, even, you might want to write this down, is when f of x equals f of negative x. F of x equals negative f of x, that's even. Odd is when f of negative x equals negative f of x. If you can prove either one of those, then you're proving it's even or odd. My advice is going to always try even first, because you have to use f of negative x for odd anyways. So, to start this out, I have a function. I am going to check f of negative x. Plug that into your function. Right here? Yes. Yes, that's supposed to be a negative out front. Oh, sorry, I know it's barely there. What is negative x squared minus 5 equal? It just equals x squared minus 5. And what's x squared minus 5? Isn't that the original thing? So this equals f of x. Therefore, f of x is even because f of x equals f of negative x. And you are done. We have just proved algebraically. Always do f of negative x first, plug it in, and then see if it matches your original equation. If it matches, you have an even function. What about the next one, g of x? I'm going to do g of negative x. Does that match my original equation? It does not match the g of x. Therefore, this is not even. So how do I check odd? Well, we already did that. What's the other part of the odd one? Negative g of x. So that's going to give me negative 5x cubed plus x. Well, what do we notice about that? Is it my original one? No. But what about the one above it? It is the same as the one above it, which is good because that means it's odd. Because g of negative x equals negative g of x. We are done. Is this making sense? A little bit? Let's do it again just for practice. F of x is x over x squared minus 1. Always start with f of negative x. Is that the same as above? Nope. It does not equal f of x. Therefore, it's not even. If I just add a negative out front, be careful that you're not putting the negative on both the numerator and the denominator. That's two negatives. Does this match right up top? It does. So this equals f of negative x. Therefore, f of x is odd. If you're writing neither, your reasoning would be neither because f of x does not equal f of negative x and f of negative x does not equal f of x. This would be your reasoning for neither. You have to separate them. I have a lot of y'all try to tell me f of x does not equal f of negative x does not equal negative f of x. You need to separate your reasoning for odd and your reasoning for even. I have 3 minutes. I know we've been writing a lot. I just want to finish this last part. It should be super simple. So stay with me, please. Increasing. What part of this is increasing? You need to give me the x values in parentheses. No brackets. These aren't points. These are intervals. From what interval is this increasing? Going up. Negative 4 to what? To 0. Negative 4 to 0. This is increasing. Always read it from left to right, like a book. Where is this decreasing? Say it louder. Decreasing, going down. Where is it decreasing? Negative 6 to negative 4. Is that it? Union with what? Be careful, x values. 3 to 6. X values. Always look at your X values. Last but not least, where is it constant? From where to where? From 0 to 3. Okay? X values, intervals, is always going to be parentheses, and you're reading it from left to right. Okay, hold on, time out, pause, because I got 1 minute. Your homework tonight. I am going to send you my answer key before you walk in tomorrow. You need to just copy what I have written down. That's how we're saving. Instead of in class me writing it with you, I need you tonight to have it all copied down. It's pages 5 and 6, so that when you come in tomorrow, I can just explain it and we can do examples. Okay? Homework tonight. I'll send it on Remind and I'll post it in Schoology.